positive legacies, in this case environmental legacies of tropical deforestation.
Thanks a lot, Dwayne. And thank you to the organisers of the challenge who have invited me to be here. It's a real pleasure. I want to talk to you about habitat loss. I'm going to do this in a tropical context, which is where I've been working for the last 10 years. But I would also like to state up front that I think this is still relevant to New Zealand. These are issues I started studying here in New Zealand when I was a PhD student, where I took what I learned away. It's nice to be coming back talking about what I've learned and thinking about how it might come back and be useful here. My main thesis is that we need to think about history when we're considering environmental impacts. Habitat loss is a process which can happen very fast, but its biological impacts can happen very slowly. Anyway, I realise this is the last talk of the conference. You are probably a bit dozy, so watch this. Hopefully. It's going smoothly so far. Let me try that again. You're probably a bit dozy. So what you should imagine you're watching, or more precisely, what you can hear in the background is the dulcet tones of chainsaws, which is reality for large amounts of tropical rainforest. The project site I work in Malaysia, where I took these beautiful moving images you can see. This is something we've been waking up to for the last year or so, is trees like this being knocked over. This one, particularly traumatic, almost 70 metres tall, God knows how old it was. They knocked it over, it was hollow on the inside and completely worthless. Yeah, what can you say about that? The reason I think that matters is that in tropical rainforests we obviously have a lot of species. The levels of diversity are ridiculous. These are maps of species, vertebrate diversity for the Brazilian Amazon. It's taken me a long time coming out of New Zealand to, it's not understand so much, I don't think I'm at the understanding point, but to recognise that people give a toss about things like rats. It's weird. But anyway, people care about mammals over there. And there are a lot of them. So these numbers up here are just forest-dependent birds, mammals, and amphibians. This doesn't count the ones which will, like your jaguars, which are going to forage out on a savanna or a farmland or something like this. This is just the ones which must have forest and are entirely dependent on forest for their lifestyle. And you can see there's this big west to east gradient going from the Andes in the west across to the coast in the east, where you have much higher diversity in the west. That pattern is really important because when we look at where the deforestation has happened across the Amazon, that's all these pink bits, it's concentrated around the south and the east. This is what's called the arc of deforestation. It does penetrate up into the Amazon along major road networks, but it's really concentrated in the places where there's not that many species. And that is a big contributing factor for why there's been 0 observed vertebrate extinctions from the Brazilian Amazon so far. You could call that good management. I call that blind, dumb luck. And you can't rely on blind, dumb luck forever for your conservation outcomes. Now, a contributing factor for why we haven't seen extinction now is that extinction is a process which takes time. You can cut your habitat down, but you're not shooting the monkey when you do that. The monkey is still there and alive, and it'll run off somewhere. And it'll take time before the monkeys or the birds run out of food, or they run out of nesting resources, or they run out of places to breed, and they slowly, gradually decline to extinction. And so we have species out there which we would call an extinction depth, the ones which the habitat will not support it. There is not enough space. This is a general ecological pattern seen around the world. It's here in New Zealand. If you don't have the habitat, there is a limit to the number of species you can support. And it takes time for that to happen. Now, traditionally, we used to model this according to that grey line there, where we made this simplistic assumption that all habitat loss occurred in one hit at the beginning of time, and then species would decline at this known rate through time. And we know pretty well what the half-life of that is. It takes about 50 years to lose half your species. That should be a warning shot to New Zealand, because 50 years ago we were still deforesting pretty rapidly. So we still will be seeing effects of habitat loss in this country. And what we did was extend this model to account for the fact that habitat loss is actually a continuous process. It's not a binary process. It happens in small amounts over large periods of time. And when you do that, the shape and the rate at which species are lost changes quite a lot, and that's what this red line is. It's a hypothetical example where the same amount of habitat is lost as the grey line, but it's lost in 4 discrete intervals. So the message here is that losing continuous habitat loss, or treating it continuously, it doesn't change your endpoint. You're still left with a certain amount. You'll still only have the number of species that can be held. But it does mean you've probably got a bigger window in which you have these species which are probably threatened and will go extinct unless you do something. And that's what we called in this paper by my PhD student, Ollie Wern, we called it a window of opportunity, really, a window of conservation opportunity to get in there while the species are still there, but before they will go extinct. So we backcast deforestation patterns across the Brazilian Amazon and used it to map out where that local extinction debt is using 50 by 50 kilometre grid squares. These are reasonably complex maps, but the more white you can see in a grid square, the more species will have gone locally extinct from that grid square. The redder the grid square, the more species are sitting there at the moment but will go extinct. That's local extinction we're talking about in this case, not global extinction. And you see in some places you're going to lose 100 or so species which are still in there. So in the Amazon context, these are the places where you want to be focusing your effort. There's a lot of species which are sitting there in that area. We know there's not enough habitat for them to persist indefinitely. We can do something about it. There's little point in putting all of your effort up into the far northwest where not much is happening. Now, if we look at this regionally and start thinking more about regional level extinction, we can construct these trajectories. This is a figure I'll come back to and extend at the end of my talk. But we started our deforestation models here from 1970 and took them through to 2010, which we considered at the time as the present day. And on the bottom is what we were predicting should have happened in terms of extinction. Now, we know there's no known extinction in there, so we've got a slight over-prediction. We predicted 5 or 10 species or something like that to be extinct. And then on the top panel is the extinction debt, which we were predicting. And the little red triangle there is the number of species that are on the IUCN Red List for this region. And so I reckon we're doing pretty well from a first principles-based habitat loss model to be able to predict with that level of accuracy. We are slightly over because we need to count the extinct species as well, but on the whole we're in the right ballpark, just considering habitat loss and ignoring all other threats. So we took this approach and we decided to extend it to the whole tropic. So the Brazilian Amazon is a big place, but it's only half of the Amazon basin itself. We extended this to model extinction debt in the Congo, the entire Amazon, and Southeast Asia. And the starting point here was to construct a deforestation model which we were able to backcast into the past. So we don't know, we don't have maps of where forest was in 1962, for example. Satellites only get you so far. So we constructed a model. These rates of forest loss across these 3 tropical regions, they're our model estimates. The model, I think, did pretty well. There's a lot of disagreement in the literature as to what the exact rates of deforestation have been over the last 2 or 3 decades. The earliest estimates sort of start in the late 70s through to mid-80s. There's a wide range of estimates, but our model predictions all recreate that rate and sit within those known estimates. So I think we're in the right place. And it follows known and expected trajectories. So deforestation really took off in the Amazon through the 80s, late 70s, and much earlier than it took off in Southeast Asia. We know there's not been much in the Congo by contrast, whereas that is just starting to hit now, and that's going to be the new wave. So on the whole, the model does pretty good. This is just summarizing the deforestation rates we were predicting. Of course, this is a spatially explicit model, so we're predicting the patterns as well. And again, it did reasonably well. So I'm reasonably confident that we have a good basis to make these predictions about extinction debt. Across the tropics, it looks like this, going through from 1950, so just after the end of World War II, through to 2009. We're predicting roughly 40 species have gone extinct. That's not too far off. I forget the exact number which the red list records, but we're not too far out of whack. And again, a huge, huge extinction debt, which is still accumulating, and is starting to approach 200 species, which is sitting out there, which we expect will go globally extinct in this case, in this analysis, in the coming decades. Now remember, that extinction is something which will take a long time. It'll be 50, 100 years before these extinctions have happened, and that's from habitat loss and deforestation, which happened up to 50 years ago. These are very slow-moving processes, but we are living with this huge legacy of these past actions. Just almost as an aside, the same principle applies to carbon emissions as applies to extinction debt. And so we did exactly the same analysis. The only difference is that the half-life for extinction is about 50 years. The half-life for carbon is much longer, about 7 years. So deforestation doesn't take all the carbon out of the system. You still have roots left behind which slowly rot out. It takes a long time for that carbon to be emitted. You have branches which are stripped off and left on the soil. It takes a long time for them to decompose. So we have the same problem. There is a carbon debt out there in the tropics, to the point where if deforestation was to stop dead tomorrow, we'd still have 5 or 10 years worth of deforestation emissions sitting in that system somewhere to come out. That means there's a big time lag in implementing a policy and actually getting the returns from that policy, which needs to be accounted for. Again, we think these estimates are pretty good, so our estimates, when we go region-specific, our estimates from the Amazon correlate pretty well with aerial measures of carbon releases. So I think we're doing a good job of recreating these processes with really very simplistic models. Now, that's one side of the story, which is thinking about the past and how that influences the situation we're faced with the present. The other is to think about, well, we're making decisions today, and they will guide what our future is going to look like. So we attacked that again, focusing in the Brazilian Amazon. We used these model projections by Bertaldo Soares Filho and his group. These were very high impact deforestation models, which were published in Nature in 2006, I think. And they modeled deforestation until 2050 under a range of scenarios. So on the left there is their business as usual scenario. On the right is their governance scenario. Think of it as a normal case and a best case. At the time we were doing our analyses, we were pretty convinced that the governance scenario was on track. There had been good changes in the Amazon control of deforestation. Brazil had implemented a lot of new policies that invested heavily in controlling deforestation. In fact, they dropped their deforestation rate by almost 3/4 in a period of a couple of years in the late 2000s, which is an incredibly impressive effort. So we were thinking that this governance scenario was more likely. And so here, this video is going to work for you, that's good news. Here we are modeling and mapping out that extinction and extinction debt across these two scenarios, business as usual on the left, governance on the right. They're exactly the same up until about 2005, 2010, because of course history has happened and it's the same for both locations. After that, they start diverging, and you can see the impact of controlling deforestation. Under governance, protected areas are holding better. You can clearly see where the big protected areas, the big indigenous areas are sitting. You can see that development along roads has been constrained, and the main thing here is you can see a lot more green and a lot more colour than you can on the left, where there's a lot more white space, which is local extinctions, and a lot more red. So really dramatically different futures, which come from an action which was imposed in the mid-2000s by the Brazilian government. And suddenly you flick from one course to the other. If we try and summarize that, we took this graph, I showed you the left part of this before. We extrapolated that out under the business as usual and the governance scenarios. You can see under business as usual, at 2050, everything is going, well, catastrophic really. Extinction rates are going nuts, and you're still accumulating new extinction debt at an incredible and accelerating rate. Under governance, you are still losing species. That's going to be unavoidable, but it's at a linear rate, and you do still have an extinction debt, but you've stopped accumulating a new extinction debt. And so there is a limit set there. And that, keep in mind, is probably, in some ways, the worst case. Because if you're out there actively doing conservation, as New Zealand knows probably better than any other country, you can have these species which are sitting there threatened. You do have an opportunity while they're still there, still extant. You can still do something about it. Anyway, this is, at the time we published this, we really thought governance was the most likely scenario. We're now looking at somewhere between the two after recent government changes in Brazil from about 4 or 5 years ago, where they revisited their forest code and made it a bit easier to deforest. So we're oscillating, but still it's not nearly as bad as the outlook was maybe in 2010, 25. So conclusions, the main thing to keep in mind here, I think, is that habitat loss impacts is something which takes decades to manifest. It's easy to forget it because I would be very surprised if anyone here has actually seen something like deforestation in New Zealand. I know my grandfather did it, my father never was involved. My grandfather's deforestation still has an impact. It's really easy to forget this history and what it means for today. It's also easy to focus on today instead of thinking far in the future, but we need to think that our impacts will take time to have to come through and be manifested. So we really need to think long term, and I encourage everyone to think long term about what you want as that end point and start working there today. I'd like to acknowledge a couple of funders, reminder of the weird and wonderful things you do see when you're in the tropics, and thank you all for coming and listening.